In the Beginning by Walt Brown, 9th edition. This is page 138. A puzzle solved. What drives the superrotation on Venus is a fundamental physics question. Uh-oh. With our understanding of supercritical fluids from pages 136 to 137, puzzles not directly related to the flood are now solved, although they still baffle the experts. We will briefly digress from this study of the flood to see another powerful effect of supercritical fluids. Why does the upper atmosphere of Venus rotate up to 60 times faster than Venus's solid surface? The atmosphere of Venus is 96% carbon dioxide by volume. In the extremely hot, high-pressure lower atmosphere, the carbon dioxide is supercritical. As the sun begins to heat the day side of Venus, the microscopic droplets floating in the dense supercritical carbon dioxide vapor quickly evaporate, expanding and lifting the atmosphere of the day side. The opposite effect occurs on the night side of Venus. That is, as the night side of Venus radiates its heat into space, supercritical vapor condenses into microscopic supercritical droplets that float within the atmosphere on the night side. This shrinks the atmosphere's volume on the night side and creates a standing wave in Venus's atmosphere, a wave stationary when viewed from the sun. Therefore, the height of the atmosphere on the day side is always higher than on the night side. So the upper atmosphere in Venus is in effect flows downhill. Super rotates at up to 220 miles per hour from the higher day side to the lower night side. See prediction 1 below. Prediction 1. The atmosphere on the day side of Venus will be found to be higher than on the night side. Therefore, a high flow rate occurs in the upper atmosphere from the day side of the night side. From the day side to the night side. Okay. See prediction. Okay. As the mass shifts from the day to the night side of Venus, pressure on the day side drops slightly, expanding supercritical carbon dioxide even more and accelerating the process. The gas giant planets Jupiter, Saturn, Uranus, and Neptune have supercritical interiors, which accounts for their extremely high wind speeds. On Jupiter, winds exceed 220 miles per hour, 100 meters per second. And here's the graphic. Figure 61, thermal images of Venus in Venus. In 2016, the Japanese spacecraft Akatsuki took thermal images of Venus. They showed a strange bow shape, highlighted by the dashed red line sweeping across the planet for days. The bow seemed to rotate with the Venus's surface rather than its much quicker moving atmosphere. Day, orange. A is day, orange. Sulfuric acid clouds are white streaks. B, white is day and gray is night. The greatest heating and expansion occurs, The greatest heating and expansion occurs near Venus's equator on the day side, so the upper atmosphere flows in a bow shape that appears as if it were fixed to the terminator, the day-to-night boundary, that rotates with the planet. The parabolic velocity profile extending into the night side resembles that of a powerful fire hose expelling water into an otherwise still lake. Venus rotates from east to west, opposite of Earth's rotation, so the sun rises in the west and sets in the east. The expansion of colder supercritical nighttime atmosphere as it rotates into the rising sun lifts the atmosphere so it flows to the east in the direction of the red arrow. To conserve angular momentum, there must be a counter thrust that acts to rotate Venus backward. This contributes to Venus's backward rotation. Interesting. Very interesting. And that is again, that is from In the Beginning, Compelling Evidence for Creation and a Worldwide Flood by Dr. Walt Brown. That is page 138.